The casting of a bell is a fascinating process that blends centuries-old craftsmanship with modern engineering techniques. This process ensures that each bell not only looks majestic, but also produces a deep, resonant tone that can be heard for miles. From the initial design to the final tuning, every step plays a crucial role in shaping the final instrument of sound. The core is carefully shaped from heat-resistant clay, reinforced with sand and organic fibers, then slowly dried to prevent cracking. After the core is fully dried, the next crucial step in the bell casting process is constructing the false bell. The false bell is an exact replica of the final bell but made entirely from layers of specially prepared clay. It serves as a temporary model that helps create the mold's outer shell before being removed. The process begins by applying a thin layer of fine, smooth clay onto the dried core. This initial coating captures the intricate details of the final bell's design, ensuring that every contour and curve is precisely transferred to the mold. Once the first layer is applied, it is left to dry partially before additional layers of coarser clay are added to increase the thickness and strength of the false bell. Each layer must be carefully smoothed and shaped to maintain the proper proportions. Artisans continuously check measurements to ensure accuracy. The clay mixture used often contains organic materials like horse manure or straw, which help improve its texture and durability. As the layers build up, the false bell reaches the exact shape and thickness required for the final cast. Applying wax to the surface of the false bell is a crucial step in creating the decorative elements and inscriptions that will later appear on the final cast. This process ensures that intricate details, text, patterns, religious symbols, or artwork are transferred accurately onto the bell's surface. First, the wax is heated until it reaches a soft, malleable consistency, making it easier to shape. Skilled artisans then carefully apply thin layers of wax onto the surface of the false bell, either by hand or using specialized tools. This wax serves as a medium for creating raised decorations, as well as for imprinting fine details that will later be cast in bronze. For inscriptions and ornamental designs, pre-carved wax templates or molds may be used to ensure precision and uniformity. Alternatively, artists can carve patterns directly into the wax by hand, allowing for more custom and intricate designs. The wax application process requires great attention to detail, since any flaws or imperfections in the wax will be replicated in the final metal bell. Once the wax hardens, skilled artisans meticulously carve intricate decorations, inscriptions, and religious motifs onto its surface using fine sculpting tools. This delicate process ensures that every detail is precise, as these engravings will be permanently transferred to the final bronze bell. Any mistakes must be corrected before casting, as they will be impossible to alter afterward. The outer mold is created using a special clay mixture, similar to that used in earlier stages of the process. This mixture consists of clay, hay, and horse manure, which, when dried, becomes extremely hard and durable. These organic materials help create a porous texture that allows gases to escape during casting, preventing defects in the final bell. To apply the outer mold, the false bell is first coated with a fine layer of liquid clay or slip, which ensures that the detailed engravings on the surface remain sharp and well-defined. Following this, multiple layers of the clay mixture are gradually built up around the false bell. Each layer is carefully smoothed and allowed to dry before the next is added. The thickness of the outer mold varies depending on the size of the bell, but it typically measures several inches to ensure durability. To reinforce the mold and provide additional stability, the clay is sometimes combined with burlap or metal wires. This reinforcement prevents cracking and ensures that the mold holds its shape when subjected to the intense heat of molten bronze. Once the outer mold has completely dried and hardened, the next step is to remove the false bell from inside, leaving behind a hollow cavity that will later be filled with molten bronze. This process requires extreme care to avoid damaging the fragile mold. The removal process begins by carefully dismantling the mold box, the steel rings and framework that have been supporting the structure. Once the mold box is taken apart, the bell founders use chisels and small hammers to break apart the false bell from within. Because the false bell is made of softer, more fragile materials like clay and wax, it crumbles relatively easily when struck. As the false bell is broken apart, workers carefully extract the fragments, ensuring that no debris remains inside the cavity. Even small pieces of clay left behind could cause imperfections in the final bell's surface. To further clean the mold, compressed air or brushes may be used to remove any dust or residue. Before proceeding with the casting, the mold undergoes additional preparations. The entire structure is inspected to ensure there are no cracks or weaknesses. Any small imperfections are repaired using fine clay or heat-resistant paste. Special vents and channels are also created to allow gases to escape during the pouring process, preventing air pockets from forming in the molten metal. Once the mold is fully prepared, it is gradually heated again to remove any remaining moisture. This final drying step is essential for ensuring a smooth and successful casting process. Once the mold has reached the optimal dryness, it is positioned securely in the casting pit, ready for the next and most dramatic phase, the pouring of molten bronze. Bells are traditionally cast using a bronze alloy composed of approximately 78% copper and 22% tin. This specific mixture provides the best balance of durability and acoustical properties. In some cases, small amounts of other metals, such as silver or phosphorus, may be added to enhance the tone. The metal is melted in a furnace at extremely high temperatures, reaching up to 1,100 degrees Celsius, 2,012 degrees Fahrenheit. This process can take several hours, as impurities must be carefully removed to ensure a high-quality cast. The molten metal is then transferred into a pouring ladle, ready to be introduced into the mold. Casting is one of the most critical stages in bell making. The molten bronze is carefully poured into the preheated mold in a slow and controlled manner to prevent defects such as air pockets or weak spots. This process requires years of expertise, as any error could ruin the entire bell. Once the mold is filled, the bell is left to cool for several days. The gradual cooling process is crucial to prevent internal stresses and ensure uniform metal structure. Rushing this step could lead to cracks or warping, compromising the bell's integrity. After the bell has completely cooled, the outer mold is carefully broken away, revealing the raw cast bell underneath. At this stage, the bell is rough and covered in remnants of the mold, requiring significant cleaning. Any decorative elements or inscriptions that were carved into the mold are now visible on the bell's surface. The bell is then sandblasted to remove any remaining clay and to smooth the surface. This stage can take several days, particularly for large bells, as intricate details must be preserved while ensuring a flawless finish. No bell is complete without a clapper, the internal metal striker that produces sound when swung against the bell's inner wall. The clapper is forged separately from a specialized steel alloy, designed to be softer than the bell itself. This ensures that over time, the clapper wears down instead of the bell, allowing the bell to remain intact for centuries. The clapper is precisely weighted and balanced to ensure an even strike. To achieve this, engineers carefully calculate its dimensions so that the force of impact is centered correctly within the bell's structure. If the clapper is too heavy or improperly positioned, it could cause irregular ringing or even damage the bell. After forging, the clapper is coated with protective lacquer to prevent corrosion, ensuring longevity and durability. Before the bell is delivered to its destination, it undergoes rigorous quality testing. One of the most important tests is an ultrasonic inspection, which detects any internal defects that might compromise the bell's strength. This test is performed after the final tuning, as even the smallest surface imperfections can affect the results. Once the bell passes inspection, it is mounted with its clapper and struck to confirm the final sound quality. If it produces a deep, resonant chime with perfect overtones, it is deemed ready for installation. The final step is installing the ringing mechanism, which may be a traditional rope and wheel system or a modern electronic striker. Once installed, the bell is tested to ensure smooth operation and optimal sound projection. The process of making a bell is an intricate and precise craft that has been passed down through generations. although bell foundries are not as common today. The Whitechapel Bell Foundry in East London remains one of the most famous. This foundry, known for producing iconic bells, follows a traditional method that requires skill, patience, and attention to detail. To make a bell, 2 molds are required, one for the inside, core, and another for the outside, cope. These molds must be crafted with precision to ensure the bell's final shape and sound. The material used to create these molds is a mixture of sand, clay, horsehair, and recycled loam. This mixture is prepared carefully to create a strong yet flexible mold. First, the foundry worker bakes some of the loam into bricks, which are then cut into smaller chunks. The bricks are scratched on their edges to help them stick together better. The inner mold, or core, is constructed using curved bricks and layers of loam. A tool called a strickle is used to check and shape the mold, ensuring accuracy. To prevent air bubbles, which could weaken the mold, the worker repeatedly flings the loam onto the mold surface. Once the core is built up layer by layer, it is baked in a kiln to harden. The outer mold, cope, is made using the same technique. It is flung with loam and checked with the strickle, ensuring an even, well-formed structure. Once finished, it is also baked to harden. Before casting the metal, the molds must be prepared with graphite. This coating prevents the molten metal from sticking to the molds, allowing for a smooth finish. In addition, if the bell is to have an inscription, this is carefully placed in reverse on the outer mold, so that it will appear correctly on the finished bell. Once both molds are ready, they are carefully clamped together to form a sealed cavity for the molten metal. The molds must be tightly secured and perfectly aligned, as any misalignment could lead to a misshapen or faulty bell. A runner box is then attached, which serves as a funnel for pouring the molten metal. 2 holes are made, one for pouring the metal and another for air to escape, much like a chimney. The bell metal is a mixture of copper and tin, which is melted at an extremely high temperature, 1150 degrees Celsius, 2102 degrees Fahrenheit. This temperature is more than 11 times hotter than a cup of hot chocolate, and almost as hot as volcanic lava. The furnace is loaded with a combination of new copper ingots, clean recycled metal, and broken up old bells to ensure the right composition. Once the metal reaches the proper temperature, slag, a crusty layer of impurities, is removed from the surface. The molten metal is then ready for pouring. Foundry workers carefully pour the metal through the runner box into the mold. The sound of the liquid metal filling the mold is often compared to the bubbling of water in a bathtub. After the metal has been poured, the bell must cool and solidify. Small bells take about 2 days to cool, while larger bells can take over 2 weeks. Once fully cooled, the molds are broken apart to reveal the rough bell inside. At this stage, the bell's edges are still rough and require smoothing. This process, known as skirting, is performed using large files to carefully remove excess material and refine the bell's final shape. This ensures a smooth edge and improves the bell's appearance and sound quality. The bell casting process. A traditional foundry manufacturing method, bell casting is a centuries-old foundry process used to create bronze bells, typically for churches, cathedrals, and public buildings. The process involves several key steps, from mold preparation to final finishing, ensuring that each bell is both durable and musically tuned. The Packard Bell Foundry in Annecy, France, one of the world's leading bell makers, used this method to cast new bells for Christ Church Cathedral in Vancouver. The process begins with the creation of a mold, which consists of an inner core and an outer shell. These molds are made using heat-resistant materials, often clay, sand, and refractory bricks. Each new mold is carefully prepared to prevent impurities from affecting the final casting. Bronze, an alloy of copper and tin, is melted in a high-temperature gas furnace. The furnace has vents that allow for air circulation, ensuring even heating. As the metal reaches its molten state, impurities rise to the surface and are skimmed off to ensure a pure pour. Once the bronze reaches the proper temperature, it is carefully poured into the prepared mold. After pouring, the bronze must cool and solidify, which can take several days depending on the bell's size. Once fully hardened, the mold is broken away, revealing the rough bell. At this stage, remnants of carbonized materials from the mold's interior are removed. The bell undergoes careful grinding and polishing. Skilled artisans then fine-tune the bell by adjusting its thickness to achieve the desired pitch. Once tuned, the bell is ready for installation. This precise handcrafted process results in bells that can last for centuries, resonating with history and craftsmanship. Once the model is selected, the outer shell of the bell is created using quartz containing natural sand. This sand is processed exclusively with water, avoiding any chemical additives. The sand's fine quartz content ensures a high level of detail in the mold. Before molding begins, a two-part molding frame is selected according to the bell's size. The frame is thoroughly cleaned and dusted with talcum powder to prevent the damp sand from sticking to it, which helps achieve a smooth and well-defined surface. The larger part of the mold is placed over the model, and damp sand is added in small increments. Each layer is carefully compacted to remove air pockets and ensure uniform density, which is crucial for the strength and durability of the mold. Special tools are used to press the sand firmly around the contours of the model, capturing intricate details. As the mold nears completion, a small indentation is made near the top to accommodate the latch. This step is vital, as the latch will later serve as the attachment point for the bell's strap. The indentation is carefully shaped to ensure a secure fit while maintaining the integrity of the mold. Once the outer shell is fully molded, it is left to set before proceeding to the next step in the process. To ensure stability during the casting process, a core support is used to keep the core in place when inverted. The smaller part of the mold is then positioned on top, completing the molding stage. At this point, an inlet is created, and casting channels are carefully carved into the mold's inner section. The two-part mold is then carefully separated to allow for engraving. Engraving is an essential step in customizing the bell. Various stamps are used to imprint designs, text, or symbols into the sand mold. Customers can request custom engravings to commemorate special occasions or personalize their bells with names, dates, or messages. With the engraving complete, the model is removed from the mold and the casting channels are enlarged. This ensures that molten metal flows smoothly into every part of the mold during the casting process, preventing defects and ensuring a uniform structure. Both halves of the mold are then reassembled and securely positioned in preparation for casting. Proper alignment and sealing of the mold are crucial to avoid metal leakage or deformities during the casting process. Early in the morning, the furnace is heated to a temperature of approximately 1,280 degrees Celsius, 2,336 degrees Fahrenheit, to melt the bell metal, which is composed of 80% copper and 20% tin. This metal mixture, known as bell bronze, is highly valued for its durability and resonance. Once the metal reaches the desired temperature, it is carefully skimmed to remove impurities, ensuring a clean and uniform composition. The molten metal is then transferred into a pouring ladle, a process that requires precision to avoid oxidation or temperature fluctuations that could compromise the bell's integrity. The molten bronze is then slowly and steadily poured into the mold through the prepared casting channels. The pouring process must be controlled to ensure an even flow, preventing trapped air pockets or uneven cooling, which could lead to structural weaknesses. The heat of the metal causes the sand mold to temporarily harden and fuse around the casting, ensuring sharp details and a well-defined surface. After the mold is filled, the bell is left to cool and solidify for approximately 15 to 20 minutes. This stage is crucial as the gradual cooling process affects the bell's final tone and strength. Sudden cooling could result in cracks or unwanted stress within the metal. To optimize energy efficiency, additional copper is added to the furnace during this waiting period, preparing for future castings. At this stage, the latch is precisely adjusted using a spirit level to ensure proper alignment. The engraved inscriptions and decorative elements are then sanded to enhance their visibility and achieve a polished look. The bell is secured in a lathe and polished with a fine steel brush, creating a gleaming surface. Specific grooves are carefully turned into the metal to give the bell its signature finish. Finally, the appropriate collar clapper is selected and installed. The brass clappers used in our bells are cast in-house twice a year to maintain quality and consistency.